All right, so we are going to study, this is part of 10.1 and it's inverse functions, and this is part 2, all right? So now we're going to be studying one-to-one functions, okay? One-to-one functions. Now, let's recall a few things we know about functions. Do you guys remember this big calculator? I believe I showed it to you guys. So a function is the one that takes one input value and produces one output value. So just remember that a function takes one input value and produces one output value. So, which is right here. Let me write it down. Function is a relation where one input value, usually is x, corresponds to one output value. And what am I missing? ds to one output value. And that output usually is a y. Okay? So we remember that. I don't need this anymore. Now, we're going to introduce another aspect of a function. So now, let me see if I could see it bigger myself. Hold on. There we go. So now, we will introduce another aspect of a function. And it's this one. It says a function is said to be one-to-one if each input value corresponds to one output value. So the definition of a function is that so far. Now, and also, and every output value corresponds to only one input value. That means none of the x values or the y values get repeated. So let's write that down, okay? A function is said to be one-to-one if each input value corresponds to only one output value. So far, right there is the definition of let me just write it. That's the definition of a function, right? Now, and every output value corresponds to only one input value. Okay, so that means that none of the x values or y values get repeated. That means none of the x values or y values get repeated. Okay, so I'm just going to give you a few examples. Okay, so it says determine if each function is one-to-one. One to one. All right, so let's do the first one. It says f is equal to 4 comma negative 3, 3 comma negative 4, 2 comma negative 7, and 5 comma 0. So we said that the x value and the y value cannot get repeated. So we have 4, 3, 2, and 5. The x values don't repeat. Negative 3, negative 4, 7, and 0. So this one is a what? A 1, 2, 1. Now, look at the second one. Eight comma 4, negative 2 comma 0, 6, 4, and 2, 6. So let's check. 8, negative 6, 6, and 2. Okay. 4, 0, 4 again. There we go. Right away. Not one-to-one function. Okay. Now, let's try this one. 2 comma 4, 1 comma 3, 4 comma 6, and negative 2 comma 4. This is 2, 1, 4, and negative 4. We're fine. 4, 3, 6, and 4. Again, not one-to-one function. Let's do another one. 1 comma 1, 2, 1, 2, 10, negative 5. 1, 2, 10, negative 5. So it is a one-to-one function because they do not repeat. Okay, the x or the y value don't repeat. Now, let's go and study the horizontal line test. Let's go ahead and do that. And horizontal line test. So the vertical line, let's go back to the vertical line test. I don't know if you guys remember, it was one that we tried to get our relation to fail, right? The vertical line test says that that a function is a relation if every vertical line intersects the graph just once. So the vertical line test says that a function is a relation if every vertical line intersects the graph just once. So then now, similarly, we have a horizontal line test. Just like we have a vertical, we have a horizontal line test. So the horizontal line test says that a function is considered to be one-to-one if every horizontal line intercepts the graph just once. It's considered to be one-to-one if every horizontal line intersects the graph just once, okay? In other words, if the a one-to-one function passes both the vertical line test and the horizontal. If one-to-one function passes both the vertical line test and the horizontal line test. Both of them, okay? So a one-to-one function passes both the vertical line test and the horizontal. So let me give you some examples. We have says determine if the following relations are first a function and second a one-to-one function. Okay, so let's do the first one. This is the first one I have. And it's gonna go like this. This one is a what? It's a one-to-one, right? It passes the horizontal and the vertical line. So it is a one-to-one. Let's write it down here. 1-to-1. Now, this one. It's just a function. We could do the vertical line, but we cannot do the horizontal. The horizontal will be both. So this one is just a function. Okay, 1-to-1 has to pass both tests. Okay, now let's do this one. Hey, doesn't even pass the vertical line test. It's not a function. That's it. Now, this one and get another color. It is a function because, sorry, it passes the vertical line. So it is a function, but not a 1-to-1. We cannot do the horizontal. Okay? And doesn't pass the vertical line, so it's not a function. Okay, let's do the next one. D, E, F. So this one and it's not a function. Does not pass the vertical line at all. I have many examples. Let's see. I'm gonna keep going. F, G, So this one, what is it? Not a function. Doesn't pass the vertical line test. Okay, and if we do G, H, this one, not a function, doesn't pass the vertical line test. It is a function if it passes the vertical line test. And if it passes the horizontal too, so it's a 1-to-1. I. And this one is going to be it is a function. Yes, passes the vertical line test and passes the horizontal test. So it's a function and a 1-to-1. Okay? Now, notice this. All of the linear, we'll do it at the end. H, I, J. So this one is something like this. What happened here? That's not a function. Does not pass the vertical line test. And this one. So it's not a function, it is a function, right? Because it is a function, but it's not a one-to-one because the horizontal line will cross two, will touch in both places. So it's not a one-to-one, okay? And look at this one, it's like the other one, the other way. Yes, it's a one-to-one, okay? When I say one-to-one, I mean passes the vertical line test, which is a function, and passes the horizontal line test, okay? So notice that all linear equations are one-to-one functions, except this one's linear equation, except when we have the horizontal or vertical line, but they all are. Now, let's go into the inverse function. So the inverse function of what? X of x is written as f negative exponent of x. So we read it f inversed. So if a function f has an inverse, then every point in f of x, in x and y, can be written as yx in f inverse. So if we write it this way, when we write it inverse, it's going to be yx. So let me just ask you a question. What does that mean? What does that mean? And let me give you the examples. It means that if we have, if f of x is equal to 3, 4, negative 2, 0, 2, 8, and negative 6, 6, what happened? The inverse, f inverse, is going to be what? 4, 3, 0, negative 2, 8, 2, and 6, negative 6. That's what it is. So to find the inverse, we interchange x and y. That's what we do. To find the inverse, we interchange x and y. That's what we need to do. Now, you write down this question. How do we find the inverse of a one-to-one function. This is the question. And the answer is we interchange x and y. That's what we do. And let's do an example. I see it a little bit blurry, but I don't know why. Okay, so let's do an example. If we have, it says find the F inverse if f of x is equal to 6 minus x. So here's the first step. We replace f of x with y. We do that. So it's going to be y equals to 6 minus x. Second step, we interchange x and y. So, okay, here's going to be an x, and here's going to be a y. Now, step 3, we solve for y. Okay, let me write it again. So we have x equal to 6 minus y. Apparently we add the y and we move the x to the side. Let's move the 6 to the other side. So it's going to be x minus 6 equals to negative y. Now we're going to divide by the reciprocal. So all of this is going to be what? Y is going to be equal, this is going to be equal to 6 minus x. All right, and my last step, step 4, I need to replace y with what? F of x. So right here, I'm going to write down f equal to 6 minus x. Okay? Now, how do we know we found the inverse? That's a good question. How do we know we find it? So let's see. That would be the next. How do we know we have found the inverse? How do we know that? So let's check. We have f of x, 6 minus x. And we have the inverse of x equals to 6 minus x. Okay? Now, we're going to pick a value of x. Okay, let's try x equals to 8. So right here, the number 8 is going to go there. And here is going to be 6 minus 8. Okay, so what do I have as an answer? -2. So I have the point what? 8, which was the one that I picked, and I got -2. Right? So then if f is the inverse, hold on, f inverse, that's how we read it. So if f inverse is the inverse, then it will include that point. Then it will include the point -2, 8. Okay, and we are going to check that. F inverse, this is the equation, the F inverse, right? And we're going to say -2. So it's going to be 6. And we do have the negative here, -2. And what do I get? I get 8. So we indeed have the point. All right? It was what? -2, 8. So it does work for both. That's how we know we found the inverse. I do have some exercises to practice. Let me do a few of those. So, and this is one of the handouts. It says, we can only find an inverse. Hold on, let's write it down here. We can only find an inverse if the function is 1-to-1. Okay, so don't forget that. We can only if it's 1-to-1. Now, let me do the exercises. So it says, try the following. Find f inverse of x. Let me do one that's just a little bit different. Okay, let's do this one. So the first step, let me go back to the step, said that we need to replace f of x with y. So let's do it. We replace it with y. Second step says interchange x and y. And the last one says solve it for y. Okay, so I'm going to add 5 here. So I'm going to be x plus 5 equals to 3y. So this is going to be equal to x plus 5 over 3. Y will be equal to that. Now, we're going to check and see. If we have, let's say we have, let me go back. I need to change this. I need to replace it again. So let me replace it again. X plus 5 divided by 3. That's the inverse. Okay. So now, let's say that x is equal to 1. Let me see. So when x is equal to 1, f of x, which is 3x minus 5, is going to be so this will be 3 minus 5 minus 2. So it's going to be 1 comma negative 2. Now we're going to try this one with this inverse and see if it works. X plus 5 over 3. And what are we trying? The inverse, negative 2 comma 1. All right, let's do that. Negative 2. So this is negative 2 plus 5 over 3. This is 3 over 3, which is 1. And we got the 1. So it's exactly the same, guys. Let me do one with this one. F of x equal to x minus 3 divided by 3. Okay, so what do I do first? Replace the f of x with y. Second, interchange x and y. Third, solve for y. So in order to solve for y, I need to multiply by the reciprocal on both sides. So this is going to be 1/3 x equals to y minus 2. I'm going to add 2 on both sides. So what I get here is 1/3 x plus 2 . Hold on. I made a mistake here, guys. We're multiplying by the reciprocal. 3 over 1 is the reciprocal. So what I have here, is a 3x. So it's going to be 3x plus 2 equals to y. What do I do now? Replace the y with the f inverse, which is 3x plus 2. Now, exactly what I did on the other one. I'm going to give a number to x. Let's say x is equal to 1. So I'm going back to the first formula, first function, which was this one. So f of, when x is equal to 1, 1 minus 2 divided by 3. This is negative 1 over 3. So 1 comma negative 1 over 3. Now that I have this, if it's the inverse, when I substitute into the, hold on, let me interchange. This is 1 over 3 comma 1. So when x is equal to negative 1 over 3. That's how I'm going to try it. So it would be 3 times negative 1 over 3 plus 2. So this is going to be negative 1 plus 2. What is negative 1 plus 2? 1. All right? It's exactly the same. And I do have let me do this one. Looks a little bit different. Okay. We have to find the f inverse, okay? And f of x is equal to x to the third power minus 1. So first, I change it, the x of x, the f of x for y. Then I interchange the x and the y. Then I solve it for y. So I'm going to add 1. X plus 1 equals to what? To y to the third power. What do I do here? Cubic root on both sides. And what do I get? Y is equal cubic root of x plus 1. Now I'm going to substitute this y for f inverse. All right, now we're going to check and see if this is really the inverse. But first we take the original, and let's say x is equal to 1. So f of 1, 1 to the third power minus 1, that's going to be 0. So it's 1 comma 0. So if that's the inverse, when I'm using this one, this has to be right. So when the inverse of this now it's going to be 0. So 0 plus 1. And the cubic root of 1 is what? 1. So it is. All right, guys. Okay, let's do one more, which is always with the same cubic root. Let's do this one. F of x to the third power. Okay, so change it for y. Now, interchange. Now, solve it for y. What do I need to do? I'm going to apply the cubic root here. So this is going to stay the same. And this one is going to be y minus 5. Okay, so now I'm going to add 5. And I did plus 5 equals to y. Okay, we can change this one too. But we're going to check this answer. All right, so let's do it. When x is equal to, I believe I'm always using 1. Okay. So it would be 1 minus 5 to the third power. This is negative 4 to the third power. I believe that's 64, but it's going to be negative 64. So 1 comma negative 64. So now for the inverse, which is x cubic root of x plus 5, it has to be negative 64 and 1. So let's try that. When x is equal to 64 to negative 64. So what's the cubic root of negative 64? Remember, it could be negative because it's cubic. Okay, that's going to be negative 4 plus 5, that's 1. It's the same as this one. Okay. I don't know if I did. No, I didn't do it. Okay, let me do this one. 5. It says f of x equal to negative 1/2 x plus 2. So what do I do first? I change the f of x for y. Now I interchange the x and the y. Now I solve it for, I'm going to solve it for y. So what I need to do is make a 0 here. We have x minus 2 equals to negative 1 over 2y. Now what we need to do is multiply by the reciprocal. Okay, so that will be negative 2x plus 4 equals to y. And the last step, we gotta change this to the inverse of x. Now we're gonna check this. So f of x when x is equal to what did I do? 1? Or let's do 2. Let's do 2. So we have plus 2. So that's going to be equal to -1 plus 2. And that's 1. So it's 2, 1. Now, if that's true, what did we get? We got negative 2x plus 4. So we're going to do 1, 2. So in the inverse, when x is equal to 1, that's going to be -2 plus 4. That's what? 2. And we just check that again. All right, guys. So this is 10.1 part 2.